Welcome to the final section for this mini series on Spring Cloud Stream. We set up the Pokemon source demo and the Pokemon processor. Now we're going to do the consumer, which is going to consume data from the processor and finally place our Pokemon in either the daycare or inside of the Pokebox. So before we get started, there are a few things we need to set up. What I'd recommend is go into the processor demo microservice and select the application YAML. And then let's just copy these properties over into our consumer demo. So go to Pokemon consumer demo, go to source, main, resources, and then go to the application properties. Let's delete the static and templates because we don't really need it. And then rename this to YAML. And then we can go ahead and post our changes in here. Set the Spring application to Pokemon Consumer Demo. And then the server port, we're going to do 9004. Everything else should be the same except for these bindings. Let's delete these bindings and we'll get back to them later after we get the source code set up. So once you have this, we are ready to go. Also, you will need to change this database table name, and we're going to change it to home_Pokemon, and copy that. Go into our Postgres. Let's name it Pokemon Home DB. I'm going to save that and then go into Postgres, go to our databases. Let's create a new database. Pokemon Home DB, owner Postgres. Let's go ahead and save that. That looks good. Save all. And then let's just run a quick startup of this application. Make sure we are good to go. All right, everything looks good. We're on port 9004. One other thing you should make sure is you have these libraries set up for the Open API and then the Apache Common. And we set them in here. Should be similar to how we set up the source one. All right, so everything looks good. I'm going to go ahead and create a few packages. So the first package is going to be the controller. Next package we are going to have as our entity. And then we're doing the event. Another package for the gateway. Repository. Repository. And the final package, which is the service. So this is going to be pretty much the same as our others. We're going to start at the gateway. And before we get started, let's just close all of our other tabs. So close all tabs. And we're going to start at the gateway here. I'm going to create a new gateway, which is the Pokemon homing event listener. And this is where it's going to pick up our RabbitMQ messages. And then based off what we get from that queue, we're going to place their Pokemon in their destined database tables. So let's go ahead and add these annotations. and then get this event listener set up. So first thing we need is a service, so Pokemon homing service. And I'm just going to go ahead and create that service real quick. So create class. I'm going to put it in the service package. And let's just annotate this as a service. We're going to go back to the event listener and we're going to set up the bean for our consumer. All right, so public consumer, and we're using the Java util function. We're going to do a homing Pokemon event. So we're going to receive a homing Pokemon event that we created in the processor. Pokemon homing arrangements. And we're going to create this Pojo here, this event Pojo. So create class, and we're going to put it in the event package. We will deal with that a little later. Basically, let's just finish up this consumer real quick. So Pokemon homing event. And actually, let's get that event set up. So we are going to have another object inside of here called Pokemon homing status. Let me see if that's similar to what we have here. Pokemon homing status and homing Pokemon event. So they're pretty much going to be the same as the ones we created earlier. This homing Pokemon event is going to be a record and not a class. And we are going to list out Pokemon homing status. Pokemon homing status list. Okay. And basically what we can do is just make sure we have it the same as what we set up in the processor. Okay, so that looks good. And then the Pokemon homing status, open to the right, pop that in here. Should be the same. Let me just double check. Yeah, so everything in here should be the same as what we did in the processor. So grab that, paste that in here. Getter, setter, builder, no args, and all args constructor. We got the homing status, reference ID, which we're going to be carrying throughout all of these events. Okay, so that looks good. We got our events, and if you guys need a reference point, I'm going to be putting this in my GitHub and posting it in the description. So if you need something to reference in the future, you'll be able to look at that source code. So log info received Pokemon. And then we're going to do homing Pokemon event dot Pokemon homing status list size. So we're going to see how many did we receive during that event. And then we're going to use the homing service to determine Pokemon arrangement. And we're going to do homing Pokemon event dot Pokemon homing status list. Yes, that looks good. So now we are going to update the service to handle determining where our Pokemon is going to go. So I'm going to go ahead and create that method inside of our service. And then let's go ahead and hop into the service so we can get it set up. This is probably going to take a little bit of time. First thing we want to do is add the all args constructor so we can inject our dependencies, slf4j for logging. And we're going to have two different repositories. We're going to have the, for two different tables. So we're going to have the Pokemon box repository. And we're going to also have the Pokemon daycare repository. All right. So let's create those repositories, and before we actually get those repositories set up, we want to create the entities that those repositories are going to act from and off of. So the first one's going to be Pokemon box, and the second one is going to be Pokemon daycare. Now this isn't going to be like exactly like how they do it in the game, but we're just doing this for demo purposes so we can understand Spring Cloud Stream. All right, so getter, setter, entity, and the table name was Pokemon box. Yep. And let's do the same thing for the daycare. Daycare. Okay, so Pokemon box. Basically, we're just gonna use the same details that we created from our other entities. So we can just copy those other entities we created before. I'm going to go to the Pokemon processor demo and then open it to the right. And we're just going to copy the same details. The only thing that's going to be different is we're not going to need the homing status because we finally placed the Pokemon in the right location. And then this Pokemon box is going to be the same as Pokemon daycare. Yeah, pretty much just keep it the same. Just keep it easy, keep it simple. We got a reference ID that we're going to be using in our controllers later to check the status of where that Pokemon went. And yeah, now we have our entity set up, so now we can go back to our service and get these repositories set up. Okay. All right, so let's get this repository created. I'm going to do an Alt-Enter here, create the class in our repository. Click OK. Actually, this is supposed to be interface. And I'll close this. Extends JPA repository. And we're going to be representing the Pokemon in the Pokemon box here. And this is going to be a repository. We want to find our Pokemon by the reference ID. So I'm gonna create a custom method for that. So find by reference ID string reference ID. All right, that looks good. Just gonna copy this because we will use it for the daycare as well. So just to make sure I'm consistent, I'm gonna go back to the service, Alt-Enter, create interface, and we're gonna set that in the repository. Click OK. Oh, day car. Yeah, we need to rename that. So refactor, rename, add a E, enter. Yes. Daycare repository. Okay, that looks good. And then extends JPA repository, Pokemon Daycare, and we're tracking them by long identifiers. And then we want to return from the Pokemon Daycare, find by reference ID. All right, so our repository is all set up. Let's get the homing service set up. So we are going to get this done. So it looks like I got another typo here. I'm going to refactor that. Rename, arrange. Oops. Arrangement. That's coming from our gateway, so yeah. All right. Now we got to determine where we are placing our Pokemon that we receive from the processor. So Pokemon homing statuses. Don't really like this, so I'm just going to rename this to something else. Let's see. Status list. This list up for each Pokemon we receive. We will be doing the following. If Pokemon.getHomingStatus, no, getHomingStatus equals Pokemon status daycare. We're going to log this out. Info for sending Pokemon to the daycare. Then Pokemon get name. And then create an entity, Pokemon daycare, new Pokemon equals new Pokemon daycare. And then we're doing a bean utils copy. Copy properties, Pokemon, new Pokemon. So we're receiving the Pokemon from the processor, and then we're going to set it to copy it to the new Pokemon here. And then the Pokemon daycare repository, we're going to go ahead and just save that new Pokemon into the database, right? So now it's found its home inside of the daycare. And let's go ahead and log that out. Saved Pokemon to the daycare. Period. And then Pokemon.getName. So we know which one we saved. Otherwise, we are going to do something else. Also, let's add a semicolon here. Basically the same thing, but we're going to change the repository. So I'm just going to grab this and paste it in. We're going to change something. So instead of Pokemon daycare, we're doing Pokemon box. A new Pokemon box. Bean utils, we're going to copy them over. Instead of the Pokemon daycare repository, we're going to do the Pokemon box repository. And then instead of daycare, we're going to call it Pokebox. Pokebox here. All right. So theoretically, we should be good here. That should get us everything set up. There are some final things we need to do. So we need to go into the gateway here and we want to save this method and then go into our application properties so we can set up the cloud stream bindings. So inside the bindings, we're going to paste that method and we're going to say incoming here from the destination Pokemon homing. And this is obviously the exchange name. And then the group is the same as before, homing Pokemon. And then consumer max attempts of 1. I'm going to add a little bit more bindings. So let's see, rabbit bindings, consumer, auto bind, dead letter Q, true. All right, that should get us set up and good to go. Let's see, save all. This Pokemon homing should be the same thing we had in the processor. So if I open this to the side, we'll see that when the processor is sending something out, it's sending it to the Pokemon homing destination. And that's the destination where we're going to be picking it up in the consumer. All right, so technically we should be done here. And yeah, we can run this, but before we do that, what I want to do is actually set up the controller so we can just view from a customer's perspective. If they have the reference ID, they should be able to see the status of their Pokemon. It's kind of like when you buy something off Amazon and you get the tracking number, you can track the status of where that package is currently. So we're going to create a new controller here called Pokemon Home Controller. And we're going to give it all of the annotations we need. So REST controller, SLF for J, all args constructor, request mapping. Request mapping, we want to do Poke Home, and the tag we'll do as Pokemon Home Controller. Alt Enter. Okay, and now we want to create the controller. All right, so this is going to be the last steps we're going to need to do, and then we can test it out to make sure everything's working as expected. So let's go ahead and set up this REST endpoint. So I'm going to add some Swagger annotations. So summary, locate, Pokemon home, and then API responses with the S. Set the value of our API responses. So we're going to have 2 of them. And yeah, let's see. So the first one is response code 500, description, internal server error. And the other one, response code of 200, description. Okay, let's just go with that. And then we're going to do a git mapping of locate by reference ID. And now we'll go ahead and set up the method. So response entity string Pokemon homing status. All right. Let's see here. Let's just go ahead and add the arguments we need. So at parameter, swagger, add a description, Pokemon homing reference ID acquired of true, and the actual parameter string reference ID. So when we kick off the process from our source, it's going to create a reference ID. This is kind of like a tracking number that we can use to track our Pokemon to make sure it got home to the right location. If it got stuck somewhere, we can track in the database tables possibly where our Pokemon got lost, right? All right, so let's check and do some string utils to validate that our reference ID is not empty. If it is empty, we obviously gotta have to send a bad request. Bad request, build, and then string status equals Pokemon homing service. Oh, I forgot to add our service in. Forgot to inject that in there. So private Pokemon homing service. And here we are going to find our Pokemon. Pokemon homing service, find Pokemon location by the reference ID. So obviously, might want to normalize our tables. There could be an easier way we could to find our Pokemon, but yeah, I'm just going to do this setup real quick and just so we can just get a result. Status of, nope, not that. HTTP status. Okay. Body. Then set the status. All right, so now we need to go ahead and find our Pokemon's location. So I'm going to go into the service and we are going to run some quick logic to locate where our Pokemon ended up at. Log info searching for Pokemon location using reference ID. All right, that looks good. I guess we will just query both the repositories. So Pokemon daycare equals Pokemon daycare repository, find by reference ID, and then Pokemon box repository, find by reference ID. And then let's do some quick if else. So if Pokemon daycare does not equal null, then return your Pokemon plus Pokemon daycare dot get name is at the daycare. Okay, else if Pokemon box does not equal null, we'll return the same kind of deal here. So return your Pokemon in the Pokebox is in your Pokebox. And then otherwise, if we don't get anything, return no Pokemon found with the provided reference ID. This means the process errored out somewhere and Pokemon got stuck in processing. All right. Anyways, looks like we're all done here. Next thing we're going to do is test this out and make sure everything is working as expected. First thing I want to do is get our source up and running. So I'm just going to go, since I have everything up and running, we should be able to see them here. So I'm going to go to the source here and I'm going to boot that up. Okay, make sure everything starts up. Okay, so it's looking for Pokemon to process. We're going to start the processor application, get that booted up as well. All right. Everything looks good. And then for the final piece, the consumer, let's go ahead and get that running. We'll see if we get any errors here. Let's check. Just make sure we're good. Pokemon DB. Okay, so it looks like right as we booted up, there was some Pokemon waiting in queue to be homed, and we received one. We sent it to the daycare, and we got Ivysaur, and we also sent him to the Pokebox. So if we look inside of our Postgres, and if I go find that table, home Pokemon DB, and then we want to find home Pokemon DB, we want to find the table. So we got the Pokebox, and let's do a select script here. Run this, and we can see Ivysaur got placed in the Pokebox. And if I go to the daycare, run this, we can see Bulbasaur got placed inside of the daycare. What I'm going to do is I'm going to run one more query and try and test it all the way through. And we're also going to check out the consumer as well. So I'm going to go localhost 9004, I believe, and then go to the Swagger UI.html. Okay, locate by reference ID here. Let's wait for that. So let's send a I guess we can send maybe like a Pidgey to the through our system and see where it ends up. So Pidgey is a normal kind of Pokemon. So let's just grab that. And he is also flying. His total power is 215. HP is 40. Pidgey's kind of weak. Attack. 40, 45, 40. 45, 40, 35, 35, 56, 35, 35, 56. Generation 1, legendary false. So we'll send Pidgey through. Another consumer you can also make is just like a consumer that could probably read off the CSV data and then take that CSV data and post it into a database. And that way, like, let's say if we got new Pokemon coming in, they create new Pokemon, we can just create another CSV and then just stream that data through. But for this demo purposes, we're just going to do a REST endpoint. So I'm going to go ahead and execute that. We got the Pokemon captured and we're sending it off either to the Pokebox or daycare. We got this reference number here. So let's just check the logs. In the consumer, we got another Pokemon received and we sent it to the daycare. We can also confirm that inside of Swagger. So if I try this out and post the reference ID that I got, let's execute this. We can see we got a response that says your Pokemon Pidgey is at the daycare. All right, so it looks like everything was created successfully. And yeah, that's basically how you can use Spring Cloud Stream to stream your data, which is pretty nice. Basically, let's say with the CSV example, if Pokemon decide to come out with new Pokemon, we could just place our CSV in a certain location and then our source should be able to just pick it up and just send it through and process it, right? But also with like the trading card example, what if we had people sending us cards they wanted to get rid of, and then we could use our source to consume it and then processor to determine like, do we want to send this for PSA grading? Is this a rare card? Or do we want to just put it in our e-commerce store to sell because it's not the best condition, not what we're really looking for? Anyways, that's the demo. If you like, please like this video. And also, I might do another demo on setting up Spring Cloud Data Flow. So with Spring Cloud Data Flow, we should be able to create jars for our the streaming service we just created, and we can plug it into Spring Cloud Data Flow. Anyways, yeah, I hope you guys have a nice day. I'll talk to you later. Bye.